Hello again. So today we're going to do literal equations, which is kind of a mysterious title. A better name for it is transforming formulas. So what we'll be doing is we'll be given an equation that has multiple variables in it. Occasionally a number here and there, but mostly variables. And we'll be solving for one of the variables in terms of the other variables. So in other words, if we had an equation that has some x's, y's, and z's in it, we might be asked to solve for x. So just like in the previous equations, our destination is to have x equals, and then everything else on this side, including the other variables. We might be asked to solve for y, which means we want y equals and everything else on the other side. So whatever variable we're asked to solve for, that's the one we want by itself, and everything else is going to go on the right. But of course, to get there from the given equation, we have to use legal steps, properties, OPE, APE, MPE, stuff that we've been using all unit. So I'm going to start with a very simple example, and that is mx equals b. This is just a one-step solution. Oh, by the way, we're solving for all of these examples. We're going to solve for x. So if we're given mx equals b, we're solving for x. We want to isolate x, get x by itself. This is our destination. So just like in our proofs, we know what the destination is. And in this case, it's a simple matter of dividing by m on both sides. So x equals b over m, and we use dpe to get there. Our second really simple example is x minus y equals f. I'll add y on both sides. And that's APE to get x equals f plus y. So we're not looking for a single number answer here. We're just looking for a transformation of a formula into a different formula that has the variable we're interested in solved in terms of the other variables. And this is important because all the formulas you know, all the famous ones out there like Pythagorean theorem and others, they didn't just fall from the sky like that. They probably came from a different form of the formula, and then someone used APE, DPE, SP, OPE, and other things to turn it into the formula that you memorized. Okay, here's one that's a little more complex. Okay, so now they're burying the x under a couple layers to hide it from you, but that's not going to stop us because we're going to carefully peel off the layers to get to our x. So using SPE, get that so I can see the x right there, and I can peel off the last layer, the C. Using DPE to solve for x, and I'm done. Remember, the objective is to get x by itself. If the right side is super complicated, no problem. I've done my job. Okay, number 4, the enemy has tried to bury the x inside the parentheses, which is a barrier to us, as we know. So we need to think of a way to remove those parentheses. Now we have two ways to do this one. Because when we've been solving equations, there are two ways we normally get rid of parentheses. We can use distributive property or something else. So first, I'll do it here using distributive property. Okay, parentheses are gone. Now the x is still buried in the mx, so I got to get rid of the mw. That was APE. And then I divide by m on both sides. And that was DPE. Okay, so that's one way to do it. Over here I'll do it a different way. Another way we can get rid of parentheses is somehow remove that m. If we can get that m out of there, those parentheses will disappear along with it. So this way is a little slicker. I get rid of the m by dividing both sides by m. That's DPE. And then I just add w. And I'm done. And you might think, wait, hold on, these are not the same. They are the same. If I take this fraction, I can write it as the sum of two fractions, these two. If you go backwards that way, you'll see how these are the same. And then in this fraction, I can cancel the m's, and I get the same thing. Okay, 5. This is a different kind of formula to transform because the variable I'm interested in, you see, is written twice. It's in two different terms. Okay, so when I see the variable I'm interested in two different terms, it's sort of like there's a clone of that x, and I want to transform this so there's only one x. I only want to see one x, like in these other equations. They all had one x. They didn't have two x's showing. So I can do this because I am using distributive property, but backwards. You're used to doing distributive property this way. Distribute the x to the p and the m, and you get px plus mx. But now I'm going the other way. I'm going from px plus mx to this. So I'm doing reverse distributive property. You can think of it as taking the x out of these two terms and putting it on the outside of this set of parentheses. It's still distributive property because properties work in both directions. And now I have just one entity times my x. So I can use DPE. And I'm done. That was DPE. Okay, the next example would be very similar to number 5. It just has a little twist to it. Okay, so this time, not only has the enemy put clones of my x in two different terms, the two different terms are on now opposite sides of the equation. But I know what to do with that. I just use APE or SPE to get both terms on the same side of the equation. So I'm going to subtract our x from both sides. And before I use my reverse distributive property, I need to get rid of that w. That was SPE. So both steps have been SPE so far. Now I'm at the same place I was before in the previous example number 5. So I will now use distributive property, the backwards form of it. And then DPE P minus R. So that's how to deal with two terms having the variable you're interested in them. Here they were on the same side of the equation, so all you had to do was distributive property. Here they were on the opposite side, so before you do distributive property, highest priority is get the x's on the same side. Okay, the last example of literal equations is this one. What do you do if the variable you're interested in is in the denominator of a fraction? This is highly unusual, and it's meant to confuse you, and it often does, but not us, because we have OPE, and OPE is powerful. We can multiply, well, in the form of MPE, we can multiply anything we want to both sides of the equation, and that really means anything. Since x is in the denominator, and I don't like fractions, plus I don't want my variable that I'm solving for in a fraction at all, I'm going to multiply both sides by x, which may sound strange, because isn't x the thing that I'm trying to solve for? Yes, it is. And it might sound doubly strange. Wait, if I multiply this by x, won't the x cancel out? And won't that x disappear? Yes, it will. And then you might, well, if there's no x in my equation, how do I solve for x? Won't there be no x's anywhere in the equation? No, there will, because this x gets distributed, remember. So yes, it'll knock out this x, but then when it multiplies with the w, it will appear here. Plus, the other side of the equation will also have an x. So we are not making all of our x's disappear. We're making one disappear and then making two others appear. So after the distributive property, well, first this is MPE, and then distributing the x, I get m minus xw equals Rx. Now I'm in the same place I was before in example number 6. I have two terms with x's in it, and they're on opposite sides of the equation. Here they are. So I'm going to add xw on both sides. Then I'm going to do my reverse distributive property. And then my DPE step. Okay, so there are your 7 scenarios. And there are more. However, if you get these 7 down, if you get these 7 mastered, there probably aren't many situations that you won't be able to tackle. These are the foundational situations that you will see. Okay, see you next time.